Basic principle of helical scroll fuel pump. Fuel has to be injected into the engine at a high pressure so that it atomizes correctly. Injection takes place over a short period of time, and this period of time must be accurately controlled, otherwise it will lead to loss of power and damage to internal components of the engine. The most popular method of controlling the quantity of fuel delivered to the injectors is by using reciprocating plunger, which has a helical groove machined into it. The main operating components of the pump are plunger and barrel. Plunger is machined to very fine tolerances. It is matched to the barrel so it cannot be swapped with others. The top part of the plunger is machined to form helical, vertical and circumferential grooves as shown. The barrel has 2 ports drilled in it which will line up with the fuel supply to the pump. Mechanism of plunger movement inside the barrel to vary the fuel delivery quantity. 2 lugs at the bottom of the plunger locate in slots in a sleeve which has gear teeth machined in the top flange. This is called pinion. A straight bar with machined teeth known as the rack engages with the pinion. The rack is connected to the engine governor or engine speed control. As the rack moves it rotates the sleeve and the plunger. The barrel, which is located in the fuel pump body, is fixed and does not move. According to the drawing, when plunger rotates in the barrel, the position of the helical groove relative to the left-hand port in the barrel changes. It is the relative position of the helical groove to this spill port which determines the quantity of fuel injected. Here the plunger is turned for maximum delivery of fuel, and the fuel pump roller is on the base circle of the cam. Fuel from the supply pump flows through the suction spill ports in the barrel and fills the space above the plunger. It also fills the space of helical circumferential and no-load grooves. As the cam rotates and the follower moves up and the plunger lifted upwards, when the top edge of the plunger covers the suction spill ports, fuel can no longer escape and pressure builds up. When the fuel pressure is high enough, the needle valve in the injector will open and fuel will enter the cylinder combustion chamber as an atomized spray. During this time the plunger is still moving upwards and the fuel pressure in the high-pressure pipe to the injector may reach several hundred bar. When the edge of the helical groove on the plunger uncovers the spill port, the high-pressure fuel flows back into the suction line and injection ceases. The delivery valve at the top of the barrel closes and the fuel pressure in the barrel drops back to that of supply pump. The plunger will continue to rise until the cam follower is on the peak of the cam. Then as the follower descends the back to base circle, the plunger moves back down the barrel under the force of the return spring. A vacuum is generated above the plunger which aids refilling when the edge of the plunger once more uncovers the suction spill ports. If a reduction in load is required, then the rack rotates the plunger, altering the relative position of the helix to the suction spill port. This means that the plunger will travel a shorter distance between start and end of delivery, thus reducing the amount of fuel pumped to the injector. Because the shape of the cam is fixed, the plunger still moves the same vertical distance as before when the engine is required to stop. The rack rotates the plunger so that the no-load groove lines up with the suction spill port. This means that when the plunger is moving up in the barrel, no pressure can be built up above the plunger and no delivery of fuel takes place. Major drawbacks of this pump. Although the end of injection is infinitely variable, the start of injection is fixed. This is not ideal for low-load operation or for dealing with fuels of differing ignition qualities, due to wear down of top edges of spill ports and plunger. The injection will be retarded. Thank you.